Okay, so I decided to re-record these notes for 7.3. I know you have two sections. You have 7.3a and you have 7.3b in your packets. I'm going to do them as 7.3. Over the years, I realized for this particular part of logarithms, I want to teach it differently. I want you guys to be able to make the connection of what a log is. So my goal is that when you see log base 3 of 27, you just automatically know that that is equivalent to 3. The same way that you know that the square root of 25 is just 5. It just becomes automatic. It wasn't automatic when you were younger. You didn't know what square root meant, but eventually you've understood it and you accept it. So that's kind of why I'm redoing this, and I feel like we can do this in one day. It's a pretty simple day. This beginning part is the whole introduction to what the heck a log is. So in order to understand logs, we have to go back and understand exponential. So when we look at this exponential function here, whoops, sorry, didn't mean to do that. For our exponentials, we just studied all of these. And so we have y equals 2 to the x would be a parent function. So if I have this as an x and a y, and I plug in 0 for x, I get 1. If I plug in 1, I get 2. 2 squared is 4. And if I plug in a 3, I get 8. I can even plug in a -1 and get 1/2. So we've studied that. We've graphed those. And if I was to graph this right now, 0, 1, 1, 2, 2 to the 4th, 3 to the 8th, and then somewhere down here, negative to the 1/2. Knowing that it's going to have a horizontal asymptote at 0 and its growth, everything looks like such. Okay, so now the inverse of that would be, back in chapter 6, we learned how to do inverses. And so the inverse function of that would be where you flip-flop x and y. And so what I'm going to do is I'm just going to flip-flop x and y in my table and just go from there. So my first ordered pair of the original was 0, 1. So now I'm going to graph 1, 0. So what used to be my y-intercept is now an x-intercept. 1, 2 would become 2, 1. So that means I'm going to go over 2, up 1. 4, 2 means I'm going over 4, up 2. 3, 8 now is 8, 3. So I'm going over 8, up 3. And what you're going to notice is sort of like a square root function, very similar. I can go ahead and do 1/2 -1. So 1/2 is my x, and then I'm going to go down to -1. And so what you're going to find out is we no longer have a horizontal asymptote. We now have a vertical asymptote. And so what this looks like is my growth curve turned on its side. Just like we did with parabolas and their inverses. It was just an inverse. It was like a parabola on its side for square root functions. So in the first one, I had this is a VA of x equals 0, right? My y-intercept, my y-axis, where originally I had this thing was my horizontal asymptote at y equals 0. So a horizontal line, now we have a vertical line. And just to kind of put it all together from, oh, sorry, didn't mean to do that. From chapter 6, we talked about any function and its inverse is symmetrical along the identity function. Okay, not really important here. We're not going to graph these, but they should be symmetrical along that identity function. So that's true for lines, it's true for quadratics, it's true for any function. Right, so that's what it looks like. So the biggest thing I want you guys to take from these graphs, we are not going to graph. These are a little tricky to graph, but I wanted you to see them. And what I really wanted you guys to see is there is no blue graph, no log graph over here, or of the inverse. Okay, and so those are all when the x value is negative. So x cannot be negative for logs, okay? Because of that asymptote, it'll never ever reach there. We can kind of go through it and explain it later on, but it won't work. And this right here, this is the definition that is a log. The log describes what an inverse of an exponential is. So it's another name for what we just had right there. So not so much about the graph that we have to worry about. It's just all the information. The inverse function is called the logarithm of x. And so what we would write here is y equals log base b of x. That's how you read these, log base b of x. Now, the base b will be a number, and of x will be a number, and y will eventually be a number. And so we can kind of, the first part of this is just exploring. We can write this way. This is called exponential. But then that little y right there is what we're talking about. That exponent is the log. So logs are exponentials. A log is equivalent to the exponent of the inverse of an exponential. I know it's a kind of crazy concept there. So if we continue forward, the first part in 7.3a, what I would teach you guys is just understanding that you can write these things with the actual word log, but you can also write them in exponential form. Just keeping in mind, it's the exponential of the inverse. You see how it doesn't say, when we were graphing exponentials, we had it set up this way, where the y value and then the x value were here and here. So when we talk about the exponential form, yes, it's just in the reverse form. The y value is up top and the x is down below. But this y value is equivalent to what this is. So this is another way of looking at it. It's just another way of writing it down. Kind of the same thing as, we learned that you can rewrite the square root of 25 also as 25 to the 1/2 power, right? They're both saying the same thing, just slightly different. So this first part is just rewriting them. Rewrite each. All of these are written with the exponents. We want to bring in the word log. Okay, so it does help to have that. We have the y equals log base b of x. So maybe in the beginning, you just want to write x, y, and b, have your parts, have this staring at you so you can kind of fill in the blanks. Base is always the same. So this is my base b. Right, and then just keeping in mind that the thing that we're raising it to is not the x, but the y value. So the y value is 3, and so the x part is the 125. So when we put that all together, we would say 3 is equal to log base 5 of 125. And the second part of these notes is really just concentrating on that back half of that statement. If I didn't have an equals, you should be able to evaluate that. What do you raise this base to get this number? That's really what we're saying. What power do you raise the 5 to get the 125? And the answer is 3. So that's where the equation comes into it. They're answering their own question. Right? In the next one, maybe you just want to label the different parts. Right? So this is my base b, this is my y, and this is my x. So we'd write log base 27. Now that's down below. It's subscript and it's smaller, like an exponent size. But then what we are taking it of, the 3 is equal to the y value, 1/3. Okay, and that makes sense. What do you raise 27 to give you 3? Well, you can't raise 27 to any power. We got to go for, backwards, right? 27 is too big. So we can raise it to a partial power. And so that's where the 1/3, remember 27 raised to the 1/3 power is equivalent to the cube root of 27. So that's kind of what we're saying there. Number 3, hopefully you guys are at that point where you can write it all down just from memory. So you're going to say log base 2 of 16 is equal to 4. What do you raise 2 to get 16? The answer would be 4. 2 to the 4th is 16. And the other way of writing that down is rewriting them in exponential form. I believe this 100 here isn't really there. I believe that's supposed to be over here. Now this one should actually make mathematical sense to you. So when you make your statements, they should tell the truth. The other one was a little harder to work through because you don't know what a log is quite yet. Excuse me. But this one, same concept. Maybe you want to have your x equals b to the y, just available. This is what we're going for. Okay, if you need to, you write your x, your y, and your b. And so I know my base is what the base here is that 3. And then of x, so that's your 9, equals the y value 2. And so what we're going to write is I'm going to take my base 3, raise it to the second power, to the y power. Remember, it's the inverse, and it should equal 9. And that's a true statement. 3 squared equals 9. So if you had those in any other form, it would not make sense. So you need to make sure that it does make sense. You can also just label the parts. Okay, this is my base b of x equals y. And so I'm asking 10 to the negative second power, does it in fact equal 1 over 100? And it does. 10 squared is 100, but it's negative, so it has to flip it to the bottom. And then the last one, maybe you're ready to rock and roll with this. 2 to the 5th power is equal to 32, and that's true. So if you have to write it down or label some things, take your time with that, but we're just practicing going from one form to the other. It's helpful to be able to interchange. So now I'm going to go into the 7.3b, so you can skip that first lesson summary and practice problem. So we're going to talk about evaluating. So I know in the very beginning here I have evaluating. I tell you to just rewrite it as an exponential form and make an equation. So you're going to be given logarithmic form, and I'm telling you, you can just change it to this form and then just solve for y. You won't have the y value. The y value will be missing. I want this use if stuck. So if you can't do it and you're stuck, this is an easy thing to do. You're going to rewrite the log just like we did in the first part as an exponential, and then you won't have a y value, so you'll solve for y. But more importantly, I'd like you to just think these through. So we're going to go through a couple of these. Log base 3 of 243. So notice there's no equals. There is no equation. We're just evaluating. This is that first part where I said I wanted you guys to be able to look at this, just like you look at the square root of 25 and make it 5. So it may take a little bit to say 3 to what power is equal to 243. That's really what you're doing. That is me rewriting it. But you're saying, what do I take this little power to make this power? What do I raise 3 to get 243? So lots of repeat calculations on your calculator. Just do 3 times 3 times 3 times 3, and I believe it is 5. Or you can use the caret and just keep guessing and checking until you get to 243. But the answer here is 5. Okay, same thing here, a little bit different. I got that 1/8. Okay, in order to make a 2, raise a power of a whole number 2 to get a fraction, that means I'm going to have to flip it. That means I'm going to have to bring in a negative. And 8 is really 2 cubed, right? So what did you raise 2 to get 1/8? You raised 2 to the negative 3rd power. Now I showed a little bit of work there, but really I'm not looking for work. I actually don't want you to have the work. I want you to be able to look at this 9 and get to the 3. Okay, well, powers of 9 are too big for 3. I do know a relationship between 9 and 3. It's not a negative part. So I knew I had to bring in a negative here because not only is 1/8 smaller than 2, it's smaller than 1, right? And so that's where I got the negative. 3 is smaller than 9, but it's not a fraction. But I know the relationship that the square root of 9 is equal to 3. So another way of writing the square root of 9, I can say 9 to the 1/2. And that's the answer. What's the log of, what do I raise 9 to get 3? The answer would be 1/2. So we're evaluating here. Stay away from the log button on your calculator. It is only base 10. We're going to use it. We're going to use it very shortly, but not yet. And so it's going to really mess you up. These are all different bases. So I want you guys to just kind of think them through. It'll help you understand these a little bit better. Now, if you do get stuck, for instance, if on number 3, you couldn't figure that part out, you can just rewrite it as y equals log base b of x. Okay, and this is what this thing equals. Okay, there is no y value. And so then you say, oh, I'm sorry. We're going to say put that in terms like this, right? So we have that equation, and then we want to rewrite it, and we're basically saying 9 to the y is equal to 3 to the 1st. And you can resort back to saying, well, I can get these to be common bases. And once I have common bases, 3 to the 2y is equal to 3 to the 1st. And then we solve this equation. That's just a lot of work for something that if you just stick with it and think it through, But you do have that option of writing an exponential equation, and it should work for you. All of these evaluates work, okay? One last thing, I want to talk about some special case scenarios. Since logs and exponents are inverses of each other, they sort of undo each other. And so when we see something like this, I see a lot of the common stuff. I'm raising a base, and this whole thing is the exponent. I'm raising b to this exponent, but the exponent happens to be a log. So I'm raising 2 to some power, and the power I'm raising 2 to is log base 2 to the 8th. You don't have to do any work. When I see this, I cancel out the 2's and I get 8. Okay, and really what that's saying, 2 to some power, right? They want me to evaluate 2 to some power. Well, once I figure out what the power is, I can evaluate it. So I go off to the side and I do this math. And I try to figure out what number that is. It's like a riddle. What do you raise 2 to get 8? Well, the answer is 3, right? What power do you raise the little number to get the big number? The answer is 3. So I evaluated log base 2 of 8 and got 3. That's what this is. 2 to the 3rd is equal to 8. It's staring at you in the face. So when you see those, I want you to not have to like think them through and do the work. I want you to just know you can cross them off. The same thing's going to happen when you find the log of something, but the thing that you're finding the log of happens to be a power. Log base 3, as long as that power of 3 to the 7th. Okay, and if you just break it down, they're saying, what do you take this little 3 number to make it, what do you raise 3 to make it equivalent to 3 to the 7th? Sort of a common sense 7. What do you raise the little number to so that it equals 3 to the 7th? The answer is going to be 7, right? So those ones you don't really have to think a whole lot through. I want you to be able to visually pick them out. We use those ones a lot for log base 3 of 3. Log base 3 of 3, there is no exponent there, but there's a really understood 1. What do you raise 3 to get to 3 to the 1st? It equals 1. So log base 3 of 3 is 1. All right, good luck. We have a worksheet for it. All of these wonderful things. Here's your lesson summary, maybe. A log is an inverse function of what type of function? And I need you to evaluate that. Showing work or not showing work, just making the connection between those two numbers. Good luck.